Well, hi everyone. I think this may be one of my more important videos if you consider the potential public service benefit, and it's because of lessons learned on a bridge that's under construction in Lansing, Iowa over the Mississippi River, the Blackhawk Bridge. I've done a number of videos about that project, and it is a cautionary tale for Rhode Island DOT, or it should be, for the replacement of the Washington Bridge, the Westbound Washington Bridge, and potential impacts to the existing eastbound Washington Bridge. So bottom line up front, you have very similar ages of original bridge foundations. So this Blackhawk Bridge was completed in 1927, which is roughly the age of the foundation for the existing eastbound Washington Bridge. That foundation goes back to 1930. They replaced the superstructure in 2008, but they reused the old timber pile foundation. And the piers of the Blackhawk Bridge were also supported by timber pile. And because of movement during construction, vibrations that caused movement of those piers, they had to close the bridge down at least a couple of times. And now they're going to close it down permanently and demolish it a year and a half before the new bridge is going to be completed. There's so many parallels between these two bridges, and it's important to learn from what's happened here. As they say, a smart person learns from their own mistakes, a wise person learns from other people's mistakes. And considering that I've done roughly 30 videos about the Washington Bridge project in Rhode Island, and I've recently done 3 or 4 videos about the Blackhawk Bridge, I'm able to put 2 and 2 together in a way that perhaps no one else is thinking about. And again, I think it can avoid a lot of major impacts, unacceptably high impacts to the existing eastbound Washington Bridge in Rhode Island. So I'm going to go through it all. Just stay with me. I'm going to give you the technical basis for everything. But it's, I think, a very compelling and cautionary tale, or it should be, for the people of Rhode Island. So the new Blackhawk Bridge is being constructed right next to the existing Blackhawk Bridge, and the plan was to keep the existing bridge open until construction of the new bridge could be completed and open to traffic, and then they would demolish the existing bridge. Well, that's not how it's worked out. So I'm talking about northeast Iowa. It's a beautiful area of the country. You have Wisconsin, Minnesota, Iowa. I just really like riding my motorcycle along those river roads. It's really scenic and wonderful in the summer. But it's a small town, Lansing, Iowa, population of around 1,000 people. The DOT just announced that because of various episodes of pier movement, because of disturbance of the pile-supported pier foundation, they're going to close the bridge this fall. They're not going to close it during the peak summer tourist season. As I mentioned, these river towns along the upper Mississippi River are just wonderful places to visit in the summer. And they're going to wait till the fall, but then that bridge is going to be closed, as I mentioned, about a year and a half sooner than expected. And so now these locals, it's about 2,500 vehicle crossings a day, will have a 70-mile detour, which is going to cost them an extra 90 minutes. So it's very impactful to these people in this area. And the bridge is being constructed by a very reputable prime contractor. So again, this can happen on these projects if unexpected conditions are encountered, or if some key things just aren't really scrutinized or understood. Now, I want to say up front, the reason why the people of Rhode Island can benefit by learning what's happened on this bridge in Iowa is because the DOT has been completely open and transparent with their stakeholders, with the public, about what's been going on, what the problems have been, what's caused the problems, and what they're going to do about it, which is refreshing. So not only do people around here know what's going on, other people, like the people of Rhode Island, can learn how to avoid having a similar fate befall them. So again, I want to thank the resident engineer with Iowa DOT. Iowa DOT is the lead entity on this project. The costs are shared jointly between the states of Iowa and Wisconsin. But Clayton Burke spent one morning with me answering my questions, talking about the project. And I really appreciate that kind of candor, the openness. That's what I'm used to. My primary area of practice is in the Midwest. And everything I'm going to talk about in this video relates to my area of expertise in geotechnical engineering. And I've done work that's almost exclusively related to construction phase testing of bridge foundations for the last 25 years of my nearly 40-year engineering career. So I'm going to bring all these experiences and knowledge that I have about this situation to bear here. But, you know, that's what I'm used to with these DOTs in the Midwest. They tend to be very open and transparent, straightforward, and driven by engineering considerations, not political considerations. Now, if they had behaved as, say, Rhode Island DOT, they could have lawyered up and said, we can't talk about what's happened. We're just going to close the bridge a year and a half earlier, and it's going to be tied up in courts for the next 7 or 8 years. And by the time everyone's forgotten about this project, then the truth will come out. That's not how they're approaching it in Iowa. But going back to the Washington Bridge, this is, again, footage from June 8th. Josh from Providence took this drone footage. They're getting ready to start, or they have started, the demolition of the pile cap, and they'll remove the upper few feet of each pile. This was a demo project that was added after the award of the demolition of the superstructure. And Rhode Island DOT has made a series of fateful decisions, which is going to lead them to create a high degree of risk, in my opinion, for having a similar situation befall the existing eastbound bridge in Rhode Island over the Seekonk River on I-195 that befell the people of Iowa and Wisconsin for the Blackhawk Bridge over the Mississippi River. So what's the issue here? Well, both the Blackhawk Bridge and the eastbound Washington Bridge, which is now carrying 6 lanes of traffic, about 100,000 vehicles a day are crossing the eastbound Washington Bridge. And you've got a pile cap that supports the pier, the bridge pier, and then you have these timber pile. And they only extend about, in the case of the Washington Bridge, they're 30 to 50 feet into the channel deposits. And on the Blackhawk Bridge, they didn't have a lot of information, but the information they did have indicated that those piles were of similar length, roughly 40 to 50 foot into the channel. And a timber pile is basically a tree trunk. The narrow or pointy end goes down and it's driven with a pile hammer. And the resistance along the sides and the bottom is what provides the geotechnical resistance to the applied loading. So a structural engineer will come in, take all the loads distributed from dead loads and live loads and figure out what the loading is at the foundation, and a geotechnical engineer will come in and determine what type of foundation element should be used. In this case, this is called a deep foundation element, although these timber pile are, again, relatively shallow. And there's a phenomenon here with the Blackhawk Bridge, as well as potential here for the eastbound Washington Bridge that's very similar to what happened to the Millennium Tower in San Francisco. I've done a number of videos about that building, which settled excessively, tens of inches. And it was a building supported by roughly 1,000 concrete pile. But the situation is if you go back to one of the pioneers of geotechnical engineering, Carl Terzaghi, he recognized that if you have a large number of piling that's supporting a foundation and you have soil below the tips of those pile, the group of pile acts like a spread footing in essence. So anything that happens to disturb the soil within that quote bearing layer below the pile tips can cause problems, which is what has happened at Millennium Tower. That loading of all those piles as a group caused the underlying soils to consolidate, and associated settlement caused problems with the building. So the new construction, the new foundations, will be drilled shaft foundations. So you have a steel casing that's driven into the bedrock through the alluvial soils, and then they have a drill that goes in, removes the soil, excavates the rock, and then they place a steel reinforcing cage and fill the hole with concrete from the bottom up. In the case of the Blackhawk Bridge, these new drilled shaft foundations are roughly 150 foot long. There's 3 drilled shafts per pier, which is exactly what's going to go in for the new westbound Washington Bridge in Rhode Island. Now, the problem with installing casing in the soils right next to a bridge that's supported by relatively shallow timber piling is that you get a lot of vibrations. Typically, these casing are installed using large vibratory hammers. And again, the subsurface conditions in Rhode Island are very similar to what you have at the Blackhawk Bridge in Iowa. You have some soft alluvial soils over some glacial outwash soils, sands and gravels over bedrock. And you can see here the weight of rod. That means when they were sampling, as soon as they hooked everything up, the rod just settled under its own weight. So basically muck, and it doesn't get much better at the depths corresponding to the bottom of the timber piling. You have loose to medium dense sands with some gravel. Now let's go back to the eastbound Washington Bridge. Each pier is supported by hundreds of timber pile, which is the same situation as the existing Blackhawk Bridge in Iowa. Now oddly, Rhode Island DOT, in their original request for proposal that was issued in April of 2024, the proposal that they got no submissions on and had to redo the whole thing, which caused a year delay in the eventual completion of this project. But they decided that they weren't going to reuse the piling for the westbound Washington Bridge. And it's not clear what that decision was based on, because they clearly didn't have the opportunity at that early stage to expose elements of the existing westbound bridge foundation. It says the results of available preliminary evaluations of feasibility to reuse the existing bridge substructures were inconclusive. Accordingly, the design build entity shall not consider reuse of the existing bridge number 700, the westbound bridge, foundation piles for structural support. The DB entity is required to completely analyze the new structures and all foundation components of all bridges for all proposed conditions and take full design responsibility for all aspects of the foundations. Well, not only were the contractors told that they couldn't reuse the existing foundations, they were also told that the new bridge piers had to be in the exact same location as the old bridge piers. So how do you put in new foundation elements in the midst of all these existing foundation elements that you're not allowed to reuse? And as a result of an APR request, I got all of the responses, the request for information that was requested by Rhode Island DOT as to why their initial request for proposal failed on the Washington Bridge replacement project. And you can see it here. The following discussion, this is one of the respondents, GZA. The following discussion is focused on the foundations for the new bridge. The original RFP did not allow the reuse of the existing pile-supported piers, and secondly, the new foundation piers had to be constructed within the same footprint as the existing piers. So again, just another example of mismanagement by Rhode Island DOT at the upper levels of that organization. Now, could the pile foundation for the westbound Washington Bridge have been reused? Quite possibly. I can't say for sure because in my view, the proper investigation was never conducted. I think it was summarily ruled out of hand by Rhode Island DOT, and I don't know why. Now, I can see the benefit by not reusing the existing foundations in that if you'd be free to have longer spans, you could have new foundations. Also, the contractor may think they don't have time to investigate the condition of the existing piling for the westbound bridge, or they didn't want the risk if they couldn't investigate every single foundation element. So, but by deciding not to reuse the foundation, it's caused a 1.5 year delay because now everything has to be demolished. And now you've increased the risk relative to impacts to the existing eastbound Washington Bridge because new foundation elements have to be installed. So how could the existing bridge foundation, the pile foundation for the westbound bridge, been evaluated for reuse? Well, you have dynamic pile testing. I'm going to show you this short video here. So we've got our data acquisition computer. We've got our gauges on the pile. Pile's being driven with an open-ended diesel hammer. I'm getting data blow by blow on not only stresses in the pile, but also the resistance from the soil and rock on the piling. So in this case, had Rhode Island DOT exposed or had a contractor expose some of the piling. They could have done dynamic testing on some of these pile to make sure they're not damaged, to make sure what the length is and the geotechnical resistance is. That would have been part of a program to evaluate the piling for potential reuse, and they just completely eliminated it from consideration. Another test that you can do, again, these methods involve exposing the top of the pile, and we just did this recently on a project in Kansas City. And it was unusual because they installed a pile-supported foundation for a future bridge. They always plan for a pedestrian bridge to go next to the roadway bridge. And this was installed 30 years ago because it was such a headache dealing with the railroad and with utilities that they said, we're in a much better position to install this foundation now than in 30 years. So the question came up, how good is that foundation that was installed 30 years ago? So we came in and did our testing. It's a sonic echo impulse response testing. And this is from a recent job that we did trying to determine the length and condition of some auger cast concrete pile below a pier cap. So we have a data acquisition computer, an instrumented hammer, accelerometer, and mounting blocks. And we mount the accelerometer to one block and we impact the other block. And we send a compression wave through the pile. And by looking at the reflection of that wave, we can determine things like change of impedance, that is change in pile diameter or condition. We can determine overall length. So this test could be used to identify locations of pile damage. So again, there are methods out there that could have been utilized to potentially reuse these foundations and save all the money, over $100 million spent on demolition of the bridge superstructure and substructure. Almost half the cost is demolishing the piers and the top few feet of the piling, which I think is excessive. I don't understand why that would cost that much. But again, it's introduced a longer time frame for the replacement of the Westbound Washington Bridge. So just as an example, let's look at this 1967 drawing set that was used for the construction of the Westbound Washington Bridge, which is now being demolished. But you have HP 14 by 89 pile, which is a pretty good section. It's 26.1 square inches in cross section. And the estimated length of piles was 96 feet. So I went back and looked at the borings that were performed to provide information to the recent bidders. The bid package for the design build replacement of the Washington Bridge was ultimately awarded to Walsh Construction. But I went back and looked at the boring that they did near Pier 4. So if you consider a pile length of roughly 96 feet, that puts you into bedrock. So it appears based on this information that the existing Westbound Washington Bridge pile foundation was driven to bedrock. In looking at the drawings, the 1967 set, they had piling that was designated as either a 150-ton pile or a 95-ton pile. So let's take the 150-ton pile. That's an allowable load, undoubtedly, so 230 kips. Back in the 1960s, construction or installation of driven piling didn't benefit from a lot of the high-end testing that we do today, the type of testing that I do in my company every day of the week, namely high-strain dynamic testing of driven piling, where you can use essentially lower factors of safety. But let's look at what was done here. Back in the 60s, they had lower strength steel, typically 36 KSI yield strength steel versus 50 KSI steel now, and they were very conservative for a variety of reasons, and would typically drive the pile to a loading of about 10 KSI. So if you take the pile cross section times 10 KSI, that gives you the total loading that you could put on the piling. So just looking at this, these piling had an ultimate capacity probably of 460 kips. They most likely used a factor of safety of 2 relative to their design or allowable loading of 230 kips. And by the way, a kip is 1,000 pounds for those of you who haven't heard that term before. And if that same piling were to be reused today, even with a lower yield strength, I think you could quite reasonably account for probably twice the capacity that was originally used. So roughly 486 kip design load or 750 kip ultimate capacity. And that would be subject to determining that the upper portion of the piling hadn't corroded, and some additional testing to make sure the links correspond to what was shown on the plans and that there was no pile damage. And I do all that type of testing in my practice. So again, the construction of the new bridge for the replacement of the westbound Washington Bridge in Rhode Island is eerily similar to the requirements for the replacement bridge in Iowa. Now, in the case of the Iowa Bridge project, the owner, the DOT, took responsibility for monitoring the condition of the existing bridge. So they were monitoring vibration levels, they were monitoring movements of the bridge piers. That's a significant contrast to how Rhode Island DOT is handling it, and I'll explain it here in a second. But because of construction vibrations, you can have various types of distortions to nearby structures. You could have differential settlement, you can have distortion of the underground soils, which lead to movement of the overlying structure, and you can have damage just due to dynamic effects to the structure itself. So this is out of the specification for that Iowa project. The monitoring consultant will develop an instrumentation and monitoring plan to monitor the existing bridge during construction activities with the potential to result in vibration-related or movement-related damage. So this monitoring consultant was retained by the DOT. So they had an extensive monitoring program, and again, I applaud Iowa DOT for implementing this program, and I think it's reasonable or appropriate for the DOT to take this responsibility and not just throw it all in the lap of the contractor, because the consequences are too great. And because of their monitoring program, they detected movement and they shut the bridge down at appropriate times and made corrective actions. Now, even though the DOT was taking the lead on monitoring the existing bridge structure, the contractor was still responsible for providing detailed information about their means and methods and avoiding damage to the existing bridge structure. They still had that responsibility. Now, what I think happened here, though, is that the allowable vibration limit was peak particle velocity of 2 inches per second, which is very high. And at the same time, they didn't specify the associated frequency. So if you have a particle velocity or movement of 2 inches per second at, say, 30 hertz or less, that tends to be very damaging. And whenever I see these higher allowable peak particle velocities of 2 inches per second or 1 inch per second, in my experience, that usually comes from blast-induced vibration specs, and is a completely different animal. You can have much higher, or you typically do have much higher frequencies associated with blast vibrations than you do with construction-induced vibrations. And it's the lower frequency vibrations that are far more damaging. And then they had criteria for tilt and settlement of the bridge piers. Rhode Island DOT, again, has a spec that says you got to monitor vibrations for existing structures within 200 feet of pile driving, or in essence, other vibration-inducing construction activity. That's what it should say, in my opinion. But they have an allowable peak particle velocity from construction vibrations of 1 inch per second, which again, I think is too high. And it mentions nothing about the allowable frequency associated with that peak particle velocity. Now, because the Europeans have, in general, far more experience in doing new construction next to very old structures and trying to protect those structures, they have a more rational specification or standard relative to determining allowable vibration levels associated with construction activity. And they account for the age of the construction, the type of vibration. Is it continuous, intermittent? Is it impact? Is it from vibratory hammers, that sort of thing? So monitoring vibrations is part of what you need to do. Here's an enclosure for a seismograph. These are the kind of plots that you would get. And in the case of the Blackhawk Bridge, the RE told me that they never did reach their threshold for peak particle velocity, but yet they had damage to their existing bridge piers, which has caused a couple of closures, and it's going to cause the permanent closure here in the fall. So again, I think the allowable peak particle velocity was probably too high. Now, for the Washington Bridge replacement, Walsh, as I mentioned, was the successful proposer. They were up against American Bridge, and in their technical proposal that was used to evaluate who was going to get this work, they talked about our proposed drilled shaft approach will minimize vibration and any resultant impacts to the existing bridge structure. Well, they don't say how they're going to do that, and I think it's really important. I know, obviously, Walsh is going to prepare a submittal, and they're going to be responsible for protecting the existing eastbound bridge. I just have questions about how much effort and concern they have about this situation given what's happened in Iowa. And I think American Bridge had a little more meat relative to what they were going to do in their presentation and their technical proposal relative to vibrations. They had a different type of foundation. They were going to use large diameter pipe piles instead of drilled shafts, but ironically, you basically have to install large diameter pipe piles as the permanent casing before you can install the drilled shaft. But American Bridge was going to limit the use of vibratory methods for installing piling to the first 25 feet to minimize noise and vibration. So in other words, they were staying above the bottom of the timber pile foundation elevation for the existing eastbound bridge. And they talked a lot more in depth about their instrumentation program for monitoring the condition of the eastbound bridge during construction of the westbound bridge, in my opinion. So there are a lot of expensive measures that you can take to avoid causing problems to an existing bridge structure while you're building a new bridge structure. And Walsh Construction, their price was $47 million lower than that of American Bridge. And American Bridge had a much better rating for their technical proposal than Walsh did, but Walsh was just so much lower. At the same time, Walsh could have bid $20 million more and still have gotten the job. So bottom line is Walsh left a lot of money on the table here. And I have to wonder if they were actually happy about getting this project. I mean, I'm sure if you ask them, they say they are, but I work with contractors. They're my primary client in my line of work. And I can tell you that contractors aren't particularly happy when they leave a lot of money on the table. Sometimes that suggests, well, maybe we missed something that somebody else caught. Doesn't, in my view, indicate that there's a lot of extra money here to do things above and beyond to protect the existing eastbound bridge, but we'll find out. Now, I mentioned how Iowa DOT handled risk. Rhode Island DOT throws it all into the lap of the contractor, and they go through all the risks that's associated with a project. You know, you need more geotechnical information. They're going to do many, many more borings out there, the design build contractor, that is. They recognize the potential damage to existing utilities, movement of existing known substructures due to DB entities' construction activities, damage to known existing structures, including adjacent bridge number 200, the eastbound bridge, and utilities due to settlement or construction vibrations. And then on the bottom here, any damage or disturbance to the subsurface soils from deep foundation installation, including but not limited to vibrations and soil displacement resulting in displacement or damage to existing structures shall be the DB entity's responsibility. So I don't think Rhode Island DOT management is being properly responsible here for this eastbound bridge. Ultimately, if the contractor screws up and you got to close down the eastbound bridge, it's all going to blow back on Rhode Island DOT, as it should. They're in charge of this project. I mean, I can think of a time where I had this silver maple in my side yard, and it was rotting in place, and I had to get contractor to come in and remove the tree. And, you know, I talked to a couple people. I didn't say, just do whatever you want, you're responsible. I made sure that the person I selected was going to work in a careful, piecemeal fashion so that I wouldn't have the risk of a big tree trunk smashing into my house. And again, Rhode Island will review what the contractor's proposing, but at the end of the day, they're just going to let the contractor do what he thinks best. And I think it's just undue risk for the eastbound Washington Bridge. I mean, it's carrying 100,000 vehicles a day. It's the only way to cross on I-195 over the Seekonk. So I just think it's unacceptable that the DOT has just taken a hands-off approach relative to potential damage to the existing bridge. Now let's talk about things you can do to minimize the risk to existing bridge structures for construction. There's what's called a casing oscillator. A casing oscillator pushes and twists a casing into place. It's not driven by impact. It's not driven using a vibratory hammer. So it's much less vibration associated with the installation of this permanent casing, which needs to be done to facilitate the installation of the drilled shaft foundations. Okay, well, that's a great installation method for the permanent casing associated with the drilled shafts, but it's also very expensive. It tends to triple the cost of casing installation or drill shaft installation on a project. So given that Walsh has left so much money on the table, I seriously doubt that they're planning to use a casing oscillator, but maybe they are. But at the same time, if they were going to use a casing oscillator, why wouldn't they put it in their proposal? Because that's a serious differentiator, in my opinion. That shows extra level of care and scrutiny to avoid damage to the existing bridge foundations. But that wasn't discussed in their proposal. So I have to think that their plan is to use conventional installation methods for their permanent casing involving a vibratory hammer, which is exactly what caused the piers to move and the bridge to be shut down for the Blackhawk Bridge over the Mississippi River. And I can't emphasize enough how I think it's an opportunity for Rhode Island DOT and now Walsh Construction to take a hard look about what happened at the Blackhawk Bridge over the Mississippi River and carefully review their planned construction methodology to avoid having any adverse impacts to the existing eastbound Washington Bridge, because the risk is just unacceptably high unless they're very, very careful. And you just can't risk closing this bridge. You know, Iowa DOT had a management decision to make. Obviously, they wanted to keep their existing bridge open, but with only 2,500 vehicles a day crossing that bridge, they wouldn't have been justified in spending an excess amount of money, in all likelihood. I mean, I doubt if they would have spent even $10 million more if it meant keeping the bridge open. I'm not exactly sure on that point, but I know it's a consideration. Essentially, keeping the eastbound Washington Bridge open until the westbound bridge is completed essentially should be money is no object. I hate to say that for anything associated with a Rhode Island DOT project, but you get my point. Would it have been worth an extra $40 million to pick a contractor who explicitly indicated what they were going to do to avoid disturbing the existing foundations for the eastbound bridge? Quite possibly. So we're going to see what happens. With that, I want to thank those of you who have contributed to buy me a coffee. That's a great way to support the channel. I also want to thank the channel members and those of you who have contributed super thanks. Again, additional great ways to support the channel. So I'll continue to follow this story and stay tuned for future videos.